Okay, in the last two parts, I introduced the concept of analytical cartography. And in this part, I would like to introduce the concept of interactive visualization, because interactive map is a subset of interactive visualization. But before that, I want to address something called spatialization, because um, interactive mapping are not only interactive mapping, any mapping is also a subset of spatialization. So spatialization, the concept is to give spatial form to something, or think of as spatial or in space relations, or localized in space. In general, spatialization means that we put something in space or gave something a context of space. So here is a pretty good example. Let me open this. This is a space. This is a visualization. Firstly, it's an interactive visualization, and it's also a spatialization. It's called the internet map. So here, in this visualization, we can see a lot of dots, big dots and small dots. They are colored in different hues, and they're positioned in this space. Okay, so this is a spatialization because we put different dots in this space. Obviously, this is not real world. Okay, so real world space is, again, a subset of space, the concept of space. So this space is internet space. And let's just zoom in. Each dot here is representing a specific website. Big dots, they are for websites with high traffic volume. The largest one here, of course, Google, right? Then Facebook, then YouTube, Yahoo, Live.com. Okay, so each dot here also has a location, has a specific position in this space. How do we decide that? It is decided, the position of a specific website, of a specific dot, is decided by its importance in the internet space. Obviously, the central dot is Google. It's the nexus of the whole internet, right? And here we say that in this spatialization, we also have different hues for different dots. Each hue is representing a specific color. This blue, this light blue is for United States. Yellow is for China. Green is for India, right? And yeah, this is a spatialization. So of course, these websites, they do not have a position or a location in real world, but you can assign spatial contexts to all those websites and put them in this space and give each one a specific location depending on its real world belonging or its importance, right? For example, the most important country in terms of internet is United States, okay? So all those United States websites, they are in the center. And in the center of the center is Google, right? And then, for example, China. China is at a corner of the internet because you know that there is this firewall between Chinese internet and the rest of the world. So it has been assigned to a corner of the internet. It makes sense, right? And also within yellow area, within Chinese internet, we have the most important one, which is called Baidu.com. It's a Chinese version of Google. You can say it is in the center of Chinese internet. So using these principles, different positions, different colors, and the authors of this spatialization, of this visualization, they spatialized all those websites on the internet. Okay, so this is a pretty good example of spatialization. Let's get back. So spatial versus geospatial, or spatialization versus geospatialization, there is difference between them, because when we're talking about simply spatialization, this space doesn't need to be the real world space on planet Earth. But when we're talking about geospatial or geospatialization, it must be somewhere or a specific area on Earth, on the planet Earth. But does it really matter? Does this difference matter? Different people have different opinions. Okay. Personally, I think it's pretty important. Okay, because like I said, this difference is huge. You can spatialization all the websites on the internet using a virtual space. But when you're talking about real world geographic entities, phenomenon, you have to use geospatialization. Okay, so here on this slide, I introduced the concept of spatialization and the difference between general spatialization and geospatialization. Okay, so now let's talk about interactive visualization, because visualization is a type of spatialization. So interactive visualization refers to a branch of graphic visualization in computer science that involves studying how humans interact with computers to create graphic illustrations of information and how this process can be made more efficient. According to this definition, geo-visualization is only a part of interactive visualization. So interactive visualization is a more broad concept compared to geo-visualization. Okay, you should know that. You should know that. So for a visualization to be considered interactive, it must satisfy two criteria. First one, it should support human input, which means that users should have control of some aspects of the visual representation of information. And then the second criteria is response time. When you make changes, when users make changes to the visualization, computer will process it and respond to this change, to these changes. So there must be a time used by computer to process, to give response. This time is this period of time is called response time. Okay, and let's talk about these two criteria separately. Human input, which means you need to have a specific method to input, to provide information to the machine, to the computer, and there are some principles. And there are some principles. The most famous one is called PHIGS. It was proposed by programmers in, I believe, 1980s. These principles were initially used for video games, for 3D video games. So according to this set of principles, in order to implement, in order to meet the requirement of human input, at least users should be able to firstly locate a point of interest, or you can say a destination, and stroke a path. In other words, a way to get to the destination. And third, choose an option from a list of options. There could be multiple methods to get to the destination. You can choose one of them. And also, you should be able to input a number or text to give orders or provide information to your PC. So that's human input, and all this input, in order to finish the input, you need some hardwares, keyboards, mice, graphics, tablets, right? Today, touch screen, right? So these devices, they form an interface between human beings and computers and machines, and you use this interface to give human input. And the second one is response time. So a delay of more than 20 milliseconds between when input is provided and a video representation is updated is noticeable by most people, which means that it's the best if you can control the response time of computer to 20 milliseconds or even faster. So it is desirable for an interactive visualization to provide a rendering based on human input within this time frame. Or if your response time is too long, you will feel the delay or the lag. If you play online video games, you know what I'm saying. And here is an example, right? Obviously, the response time of this dog is too long. The ball has dropped for maybe a second or 2 seconds, and then this cute dog responded. This is a bad example of long response time. So in order to design an interactive visualization, no matter it's geographic or not, response time is important, okay? And some example of interactive visualization, this VR Hamlet is an example, right? It's for virtual reality, right? Where humans can explore information as if it were present or was sized appropriately. If you are looking at a people in VR, this people size should be the real people size, right? And had a specific shape. Okay, so today, these goggles, they are not expensive, right? And beyond that, we even have something called omnidirectional treadmill. If you have ever used a pair of VR goggles before, you know that in order to move in the virtual reality, you have to actually move in the real world, right? If your room is very small, you could just run into something. This treadmill here is to fix the problem, right? When you move in the real world, you are actually moving on this treadmill. So you do not, and this treadmill will just move accordingly. So you do not have to actually move in your room. So uh, they are actually not that expensive. I looked up online. The one on the right, is actually less than $1,000. The left one looks more badass, looks like a prototype. I'm not sure the price, but you know that using advanced technologies today, interactive visualization could be very real, could be very advanced. So interactive maps as a part of interactive visualization is only a tip of an iceberg. Okay, what we use here in geography, in GIS, is just a small part of interactive visualization. Okay, so another type of interactive visualization is called collaborative visualization. It means that multiple people interact, not simultaneously, but with the same computer visualization to communicate their ideas to each other or to explore information cooperatively at different time. A good example would be this. Let me say, okay, let's just wait. Here is an app. It's called Access Now. Access Now. The purpose of this app is to build a collaboration community to show people different places with accessibility services within your city. Okay, so when you're, for example, you can just download this app, and when you find an accessibility service like a handicap parking lot or anything like that, you can just put a pin on your map, telling people that okay, you can come here if you need accessibility service. And multiple people, obviously, they can do the same thing at different time using the same app. They're collaborating to finish the visualization. And they're actually interacting with each other, but not simultaneously. Not simultaneously. So that's another type of interactive visualization. Okay, collaborative visualization. Okay. At the end of this part of the video, I want to introduce another concept beyond interactive visualization. Not beyond. Let's just say beyond simple visualization, we have scientific visualization. So okay. So according to the definition by Friendly, so scientific visualization is primarily concerned with the visualization of three-dimensional phenomena, where the emphasis is on realistic renderings of volumes, surface, illumination sources, and so forth, perhaps with a dynamic component. Okay? And the purpose of scientific visualization is to use graphics to illustrate scientific data. Be careful here, not any data, but scientific data, to enable scientists to understand, illustrate, and glean insight from their data, which means scientific visualization is not only for showing things, but also for asking questions, for analysis, for getting more information from what we know, right? Getting information from what we have learned from the real world and ask more questions and analyze data and get conclusions, right? Okay, so this is the end of this part of the video. Thank you.